where this study came out of is exactly the numbers that Sheila was quoting to you, is looking at the rankings for the Charlotte, Gastonia, Salisbury region in terms of cities and looking at the rankings for the counties, and in particular looking at Rowan and Mecklenburg County. And these are alarming rankings coming out of the American Lung Association, things that we really do need to think about when we're talking about air quality. And so having this going into the study, one of the things that we first need to think about, so everybody's seeing this okay, is what are we talking about? So we're talking about pollution by ozone, and what is ozone should be the first question that you always need to ask at this point. So there's a recipe for ozone in terms of how do we make it, and the critical components in the atmosphere for ozone are NOx, nitrogen oxides, VOCs, which are volatile organic compounds or volatile organic carbon, and then sunlight and heat. And sunlight and heat, obviously in North Carolina in the summer, is never a problem. It's always around. All right, NOx and VOCs typically are vehicle pollutants. They also come from stationary power sources. And so as long as you've got quite a bit of traffic or high power output, you're going to find ozone production in the southeast. And so we are not surprised to see high ozone levels. It's just expected in an urban area. But the question becomes, how high are they, and how high are they in different places? And so when Sheila approached me, because I didn't know the American Lung Association rankings, and she said, did you know that Rowan County is ranked? And I went, okay, I'm not surprised, but I hadn't thought about it, to tell you the truth. And I don't live in Rowan County, so that might be part of the reason why. But to know that all the factors are still there, and if you think about ozone as being the product of this recipe, what that means is that it doesn't have to, the county that you're looking at doesn't have to be the source of NOx and VOCs and heat and sunlight. They simply need to be in the proximity of the source. And so when we look at the counties, we're looking at counties that surround regions perhaps that have the higher level of sources. They are not necessarily sources themselves. And this ozone, one of the things to remember is we have ozone, and ozone is still ozone no matter where you put it. In the stratosphere, which is well above us at 15 to 20 kilometers, it's really important. We don't want to have the ozone hole. That's our UV screen. Really critical. It's the same compound, by the way, but this is, we're talking more at Earth's surface. This is the stuff that's not so good for us health-wise. And so same compound, different location, they call good up high, bad down low. So we're talking about ozone that's at the Earth's surface. When we talk about measuring ozone, one of the things that we need to think about is when is ozone highest during the day if you're trying to pinpoint that. And so I like this graphic just from the standpoint of showing, if you look at what I call the precursors or the pollutant sources, the NO and the NO2 are your NOx compounds. The aldehydes and your non-methane hydrocarbons are your VOCs. So those are your two pieces of your puzzle. If you look at those, they peak, time of the day is on your x-axis. They peak earlier in the day. Your oxidant, your ozone, is showing up later in the day. Okay? And so if you look at ozone concentrations throughout the day, they're getting higher as the day wears on. And then they do go down at night because the sun goes down. All right? And the sun goes down and ozone's very reactive, and so ozone goes away. So this is useful for us just in terms of understanding when our sources are coming into play and when we would expect to see ozone peaking. And this is also, if you're a runner, this is the idea that you really don't want to go running at 4 o'clock in the middle of the summer, which if you're a runner in North Carolina, you don't want to go running at that time of the day for lots of reasons. Mainly it's like 98 degrees and 98% humidity. But it's important to understand that. Where do you as the public receive this information? You receive it in the air quality index. So this is when you turn on the news in the morning or the radio, you're hearing it's a code orange, it's a code purple, it's a code red. If you have kids in school and you have kids in summer camp, what you know is that if it's a code orange day or a code red day, they're not going to spend as much time outside that day as they would on a code yellow or a code green day. And this is a reflection of ozone levels are going to be higher as basically the intensity of the color becomes more alarming. Okay, the colors were not by accident. Obviously, when we see purple, we're more concerned than we are when we see yellow or green. And so this is where the information comes to you in terms of the numbers. You don't see these guys over here, which are the correlating concentrations. And those are what we're looking at, are the concentrations that go with the colors. And the rankings also come from looking at the numbers of days in each of the ranking categories. So we had the conversation, Rowan is ranked high, we're trying to do education in a whole bunch of other counties. It'd be great if we had numbers. And so the hypothesis that comes out of that, the reason that we're going to do the study, is that because ozone's what we call a secondary pollutant, it's a product of other reactions, we expect that to be fairly constant across wide ranges of areas. And we've seen this in Davidson, that you can measure ozone downtown, out in the country, wherever you want to. You're going to get about the same concentrations of ozone. And that's because it's a product of other reactions. So we don't expect to have local variation. We expect to see regional concentrations that are indeed the same. So we went into the study with that hypothesis to see whether or not it was true or false. The other part that we wanted to study was NOx. Remember, we have two pieces to our recipe, NOx and VOCs. and ozone is our product. And so NOx does demonstrate local variability. If you measure NOx on a really busy intersection and you measure it out in the middle of the field, you get different numbers because NOx is coming out of the tailpipe of a car. And so we expect those concentrations to be higher where there's more traffic. So we wanted to measure NOx simply to be able to kind of describe the site at which the collection was occurring. So if we had a site with really, really high NOx levels relative to another site, we may need to think about what that data looks like from that standpoint. Because the goal here, remember, is to compare all different sites that are the same, inherently just in different counties. And so we wanted to have that as a measure. All right, so where were the sites? So in other words, how far did June drive? Okay, so if we look at the counties, we had sites all the way from the far east side of Davidson County all the way down into Gaston County. And so these were where our samplers were placed for the summer, for the 8-week period, and I'll talk about the samplers as well as the period. And this is the data that were coming into the rankings. So for Rowan, Mecklenburg, and Forsyth counties, if you look at the number of orange, red, and purple days as a function of their study period, and for the rankings, this data I think is 2007 to 2009. I have to remember to go back and look at those years. But this is older data. This isn't last year, but that's where the rankings come from. And so this is where we decided to study, all surrounding Mecklenburg and Rowan County where the rankings are relevant. All right, so how do we do this? Because that's your first question. When you get ready to measure something, how are you going to measure it? We use what are called passive air samplers, and they are literally this big. Okay, so we're not talking about huge instruments that we're taking out into people's front yards and leaving them there for the week, and they don't require any power. So you have a centerpiece, and on each side of the centerpiece you have screens, which are these little gray pieces, and that's just to keep the stuff off of the filter, and the filter is the white piece, this one right here. And there's one on each side, so we get replicates for every measurement. The filter is coated with something that reacts with ozone or with NOx. And then what we do is we analyze that filter for that reacted compound. More reaction gives us more compound, less reaction gives us less compound. We then can calculate back to get to our ozone and our NOx numbers. And this has been a proven method to get to ozone and NOx concentrations for a very, very long time in remote areas where you don't have any power in particular. And also expense-wise, they're not terribly expensive. And the only real cost to this is coming in the analysis, which, by the way, students are fantastic because they're cheap. So, so where were the samplers? They were in all these different counties, and so this is just a whole bunch of different pictures of the samplers. We take the samplers and we put them inside the shelters, and so on the left is the ozone and on the right is the NOx, and that's just to keep them from being rained on effectively. If they get wet, you're done. All right, so I also told everybody if it's raining, just leave them out there. Don't bring them in when it's raining, because once the filter gets wet, you just can't analyze it. And so they were placed on trees, they were placed on telephone poles, they were placed in people's backyards, about this far above the ground. They always said, how high do we put them? I said, I have to be able to reach them. So that is a limitation. I'm not that tall. All right, so you have to go out. You can put them as long as I can reach them, you're good to go. And so this is where they were. And the goal then was residential communities. We're just looking for people who live, wherever. The question is, what's your ozone in your backyard? And so we had these residential communities all the way across the counties with these collectors. And the beautiful thing about these, and I've had them in Davidson for years, is if you don't tell anybody they're there, nobody notices. It's a great thing, because once people notice things, what do? They pick at them. They do. And then they call you, right? Because what is this and what are you doing and all that good stuff. So they're great because people just don't notice them. All right, so how did we sample? We started this actually on May 31st, which is not colored there, and we went for 8 weeks, and our weeks actually went from Tuesday to Tuesday, and that just happened to be how it worked. I think Memorial Day dictated that. That's how we started. So we ran Tuesday to Tuesday, which means the numbers you're going to see, if you're a number person, represent 7-day averages. Okay, so we put the collectors out there. They were out there for 7 days, monitoring ozone for 7 days, and we're essentially getting an average concentration. So we're not going to see purple, orange, or red because we're not looking at peak values. Okay, we're looking at an average of the concentration over the week. That's perfectly fine because the hypothesis is county to county to county. So Rowan's, there's already monitors. EPA has those out there. If we know Rowan is high and we know Mecklenburg is high, our question is Davidson high? Is Cabarrus high? Is Iredell high? In terms of comparison, what does that look like? So it works out fine. So we had 8 weeks. So this is June's car every week on Tuesday, going to all these different counties and bringing them back to us so that by the end of the summer, which, by the way, the students finish working right here. So if you tell students that you're getting, what do we have, 56 samples? on Tuesday, and I know you're packing your suitcase on Friday, work really hard and work really fast. And that's basically what they did. So we had lots of data. All right, so now what does the data look like? So this is starting with NOx, and we'll talk about ozone in a minute. This, for me, was the calibration of the sites. We said we're going to pick these 7 residential sites. We're assuming all sites are the same in order to look at ozone. If that's the case, then I would like to see that NOx is always the same across all of the counties. And so if you look at every single county, we saw county-to-county variation, all right, which was relevant. And the thing was with that is that, okay, maybe our residential sites are not all equal. And if you go in and you look at the sites and where they are, some of them are closer to interstates, some of them are closer to busy highways. So there's going to be some variation in those sites, and that's reflected here. Okay, so I had that in mind when we went to the ozone data. I said, all right, some variation in the sites based on pollutant input. We may see something with ozone, we might not. It wasn't the end of the world, we just needed to know it. If you look at NOx across the summer, so this is June all the way over to week 8, on average it's about the same. Okay, the only reason that would cause it to be different is for some reason during the summer everybody just stopped driving. Okay, that doesn't happen during the summer, people are on vacation. Traffic doesn't really change at any of these sites during the summer, so we don't expect from week to week to week on average to see much of a difference in NOx. So this was not surprising to us. What we're after is ozone. All right, so what we're after here is there a difference in the counties with monitors and the counties not? In other words, because DeForest is not ranked, it doesn't have an ozone problem, right? There's a magic wall in between Rowan and Cabarrus County that keeps all of the ozone in Rowan County. It's a neat idea, but it's not valid. So if you look at on average across the counties, they're all the same. Okay, so it doesn't matter which county you're in, you're just lucky to not have a monitor. That's the only reason you're really not ranked. Okay, that's basically the point that we get to there. If you look at this on a week to week to week to week data and you do the statistical analysis, you actually do find some variation. And so when we do that, we find that Iredell actually is different than Rowan and Davidson. And we find that Cabarrus is actually different than Rowan. The negative to that, by the way, for those of you who are going, yes, we're different, is you're higher. And so different is not necessarily good unless you're lower. And so there is some differences, but that's only when you take in week to week to week to week variations. Okay, but otherwise, across the counties, on average, everybody's pretty much the same. That's fine. Ozone's part of an air mass. It's a reaction product. It's a secondary pollutant. It's going to be the same. So hypothesis was proven. If you look at ozone week to week, it does vary. Okay, why does it vary? Well, because it rains. Because interestingly enough, on week 3, it was cold this summer by North Carolina standards. All right, and if temperature goes down, then one of your recipe components goes down, your ozone goes down. So we expect to see our ozone to vary with weather patterns, and we did see that, and that was good to see. What I was really excited about, and I think the day that we were looking at this data, I said, look, but all the counties went down together. All right, and that's good for me, because then I know I've got a great set of volunteers, and I've got a great set of students, and everybody's doing everything right. This is the only calibration method I have. So it dropped, and that's great, but it was weather related. All right, if you look at the summer of 2011, and you just look at it in terms of the number of days, we had 18 orange days through the sampling period. So this gives you an idea, as we go into the next American Lung Association report, this is how we're coming out of this past summer. Okay, so what do we conclude from this study? Surrounding counties have similar ozone levels to those found in the ranked counties, Mecklenburg and Rowan County. If monitors were present, it's likely they would have the same results as you're seeing in those counties that do have them. And the big thing that comes out of this in terms of folks who live in these counties, whatever we're telling Mecklenburg and Rowan County in terms of their ozone levels and the precautions that they should be taking, so should you. Okay, so if Charlotte is reporting a code orange or a code red for that day, essentially everybody should be following suit because it's probably what everybody's going to have for that particular day. So that's what we got out of this study. We weren't surprised, okay, but we were glad to see that at least we have data to prove the kinds of things that we're trying to show people in terms of the education. So one of the things that we were looking at in addition to the cross-county is what controls ozone production in the Charlotte region. So if you're going to try and curb ozone, you have to understand how it's produced and what you're going to curb. And if you look at the recipe, we don't have a lot of control over heat and sunlight. Okay, we can try, but we don't. NOx and VOCs are our 2 places to reduce ozone. Okay, and this is why they tell you not to drive. To reduce ozone, we're going to reduce our NOx and our VOC production. So if you're NOx sensitive, in other words, if your ozone production is controlled by NOx, so this is the analogy to this is you're baking a cake. Okay, So if you're one of those people who always has flour in the cupboard, the only way to bake your cake is if you remember to buy butter. Okay, so you're butter sensitive. You can't make the cake unless you have butter. So NOx sensitive is you can't make ozone unless you have NOx, which means you have a ton of VOCs. They're always present. You're never worried about enough of those, but you need NOx, okay, which basically means you need people to drive their cars to make ozone. So if NOx goes down, ozone goes down. So if you want to decrease your ozone, decrease your NOx. Okay, so that's a NOx-sensitive environment. Which also means that if people are not driving as much on the weekends, we should see ozone drop on the weekends. And ozone should stay high during the week. Okay, that's if we're NOx sensitive. If you're VOC sensitive, so this is the person who never has flour in the cabinet but always has butter in the fridge, all right? Then you need to have VOCs. You've always got NOx. You're missing VOCs in order to make your ozone. What you see in a VOC-sensitive environment is that because VOCs are not just car-produced, they're also tree-produced. Volatile organic compounds, anything that has a smell is basically a volatile organic compound, which alarms some people, but it's true. All right, so as long as you've got lots of trees, you have lots of VOCs. That's that wonderful smell when you walk into the woods to go for a walk. Those are VOCs. And so you don't need cars, all right? But this is a situation where you don't have a lot of that. So you've got to have VOCs in order to get your ozone production going. You've got plenty of NOx, or it's not as sensitive to that. If you're VOC sensitive, what you get is something called the weekend effect. And the weekend effect is that you actually have higher ozone concentrations on the weekend than you do during the week, which is completely counterintuitive to most of us who think about ozone. Because we're like, it's about cars, right? People commute during the week. We're going to have high ozone during the week, not on the weekend. I had a student working on a project 3 summers ago who was doing ozone just for kicks, honestly. Doing it during the week, doing it on the weekend, came into my office multiple weeks in a row and said, our ozone is higher on the weekend than it is on the weekdays. And I was like, first of all, you're doing the analysis wrong, right? That's the standard professor response. It's your fault, you're doing it wrong. And so we ran through all the data and everything, and I was like, okay, you're not doing it wrong. And then I had really smart students, and so the next thing they do is they show up with a stack of papers that says, this is not the first time we've seen this. Okay, so that's what they do. And this is called the weekend effect. We have very preliminary data, and I was like, no, because what this means is that we are now VOC sensitive, which means that we don't any longer look like a region that has lots and lots of trees. Okay, now, because the place where you see this, if I can go back, look at where you see VOC-sensitive ozone production. You don't live there for reasons. Okay, you live here for other reasons. And so we don't want to join this crowd when it comes to air quality. And I was like, okay, fine, preliminary data, let it go. Well, you don't let anything go for long. So this summer I said, I've got Alexandra, I've got Juliana, we're collecting data anyway. Let's see how we look. And so in addition to doing the cross-county, we were doing weekday and weekend measurements on ozone in Davidson. All right, and Davidson's not very big for anybody who's been there. But remember, ozone's pretty much the same everywhere, so we can put monitors wherever we want to, and then we've got NOx. And if you've ever been in Davidson, which if you don't live there, the only reason you've been there is to get off of 77 to go down 115 because you thought it was going to be faster. And so this is that particular route, which, by the way, you figured out it's not any faster. So we have a monitor that sits right here, which is the intersection of Concord and Main Street, and so the traffic is either going down Main or it's coming across Concord. And then we also have a monitor down by the elementary school for reasons I'll talk about in a minute. So the premise becomes that if we are looking at the weekend effect, we should see higher ozone on the weekends than we do during the weekdays. These 2 sites for ozone, and I've got them paired by weeks. So Concord and Main is the busy intersection, and then the school site. Notice that the 2 sites are pretty much the same for ozone. If 7 counties are going to be the same, I would certainly hope these 2 sites are going to be the same. And they are pretty much the same all the way across. The blue bars are the weekends, and the colorless bars are the weekdays. Okay? So look, blue bars are always higher than colorless bars. Ozone is higher on the weekends than it is during the weekday. So that was piece number 1, which was not good news for us. So then the flip side of this is that if you have the weekend effect, what you should see then is that NOx is lower on the weekends than it is during the weekdays. NOx, remember, is site-specific. So you do see NOx higher. If you look at the left, it's always higher than the right. So that's the busy intersection is always higher than the not-so-busy site. But if you look across the time that we did the study, for the most part, you'll see that NOx is lower on the weekends than it is during the week. So the conclusion for Davidson, which means for pretty much everybody, is that we saw the weekend effect this past summer, all right? Which means then that we are not NOx sensitive, we are VOC sensitive, which means we don't look so much like we used to a number of years ago. All right, we're looking a little bit more urban. The other part of this is as you begin to think about how to reduce ozone, the standard response was to reduce NOx. That might not be the best policy at this point in time. We may have to think more about reducing VOCs because we're not so sensitive to NOx anymore. If anything, NOx reacts with ozone, so it has a wonderful effect of reducing your ozone. It's a whole other discussion. But it's just something to think about. Again, this is just our first full summer study on this, and so I still consider these results preliminary. As a scientist, you need like 10 summers before you actually believe anything. But in terms of the start of this, it wasn't exactly what I hoped to see 2 summers in a row. So the very last thing I want to talk about is looking at NOx concentrations. And this study now is a few years old, but still pretty relevant. We looked at school traffic on NOx concentration. So NOx, remember, is local. It depends on where you are. This is where the school site and the intersection were different. And I had a phone call or an email or something a number of years ago. We had a crossing guard who died of lung cancer. And so this is how emails filter down eventually. She was a non-smoker. The only thing was that she had been the crossing guard for year after year after year for the elementary school. And so the question that I got from the community was, is there an issue with air quality on the street leading to the elementary school? That was the question. And I did no field monitoring at the time, and I was like, I have no idea. But we'll take a look at it, because what else do we have to do? And so I went. So the first thing I said is, at that time, my kids were not in school yet. They were still preschool, and I wasn't going to the elementary school. And so I have students. I sent them out there. I said, go tell me what traffic looks like on this street, which, you can tell students to do anything, and off they go. So I said, go do some counting and come back. And the students, and I didn't know about car lines. I didn't realize people drove their kids to school. I think I'm now guilty of that myself, but I didn't realize that everybody did that. And that we still have buses that run that still take the kids to school, but everybody drives their kids to school. I found that out when my students came back and said, we counted 500 cars this morning dropping off kids. By the way, the population at Davidson Elementary, I think, is 1,100 right now. So to have 500 cars dropping off only 1,100 kids was a little alarming. I said, well, maybe there is a problem with air quality on this particular street. And that street at the time, this is an older map intentionally, this is the street that goes to the elementary school. It was a dead end. So every car that went down that street had to come back up that street. So you got twice the amount of traffic for every kid. Now that street actually continues, but most people, by the way, live in Davidson, so they still come back up the street. They don't go through the neighborhood on the back. So I said, okay, let's take a look. It's NOx. Let's do lots of locations. So we put one at this corner, our favorite corner of Davidson and Concord. We put one down by the school. We had one out on the back of campus. And then what I wanted to do was pick a residential street that looked a lot like the school, but wasn't the school, because they're still going to get that same kind of traffic. And so we had one, Lorimer Spring, out in here. All right, and so it really wasn't very far from the school site, but it didn't have bus traffic and it didn't have school traffic. So these are the traffic counts. These are, you have students when you can say go count cars, okay? That's just how you know you've got students. And so I went in and I said, I want you to count when school starts, and I want you to look around lunchtime and look at the end of the day. We did 2 studies, summer 2007, spring of 2008. And so if you look at the traffic sites, so that's Concord and Maine, that one where you're trying to avoid 77. On average, when school is in, we got about 900 cars, and when school is out, you got 900 cars, okay? So there's just a lot of traffic going by that site in an hour. If you look at the school, you got around 540 when school is in, 55 when school is out. Nobody lives down that street, so it's not as if you're going to have traffic when school's not in session. And at the end of the day, 300 when school's in, 17 when they're out. Okay, so there's clearly more traffic when school's in than when it's out. That's good. We did the same kind of thing in the spring of 2008, and again, you see you've got lots of cars when school's in, not so many when they're out, and teacher work days fall in there somewhere in between. If you look at NOx, the traffic site is higher than the school site, which is higher than the residential site, which is higher than the remote site. This, for me, is just our sites are fine. We picked sites that are representative of traffic, and that was all good. And this was averaged across all the data. So school in, school out, I didn't care. Just come back and tell me I've got sites that are different from each other. And so that worked out well. All right. So then we needed to compare the data for when school was in session versus school was out of session. And what we did was 5 days versus less than 5 days. And now as a parent, this makes complete sense. To have school out of session for an entire week occurs twice, all year long. Okay, that's spring break and somewhere around Christmas, when my students aren't there. Okay, this is the other challenge. All right, you're not doing any monitoring when your students are on break too. And so I was like, all right. So here's what we have, 5 days versus less than 5 days. So teacher work days, spring break, Thanksgiving, all of that's captured in here. If you look at the traffic site, and these are 3 different times, so summer 2007, fall of 2007, spring of 2008. If you look at that Concord and Main site, it didn't matter if school was in or out. Okay, levels stayed about the same. If you look at the school site, there is a difference between school in for 5 days and school out for 5 days. So there is some impact on these streets. If you look at the residential site, you don't have any impact. Okay, so the residential site just doesn't really care if school's in or school's out. So that means that that traffic, the number of people driving back and forth, including the buses, on that particular street is impacting air quality on that street when school is in session for the full week. The thing I couldn't figure out how to do at Davidson Elementary was to make everybody stop driving so I could just measure the buses as a control. All right, but you can convince parents to do only so many things, and that's not one of them. The other thing we were curious about was this NO to NO2. So nitric oxide NO is the first thing that comes out of the tailpipe, but as soon as it hits the air, it becomes NO2. All right, so this is kind of a primary-secondary argument. If you look at it, it's higher at the traffic site. Again, this is the same pattern we saw for NOx. All right. In other words, you've got more at the more primary pollutant at the traffic, less as you go down. We would expect that. The question I had was, does it matter if school's in or school's out, what that looks like? And if you look at it in terms of the school site, so this is just focusing on the school site, 5 days is gray, less than 5 days is colorless. You see a consistent decrease across those in that ratio, which means that it is actually a function of the number of cars that's driving that's causing the shift in your NOx. NOx looks at the sum of these two, and I was curious to see which piece of it was changing. And so it looks like the NO is actually changing as you go across this piece. All right, so what did we get out of here? The observed differences between the school and the residential site, and I didn't actually show this data. If you take school and put it completely out of session, which is the only control you can get, right? So I had Thanksgiving and spring break, 2 data points. The school site looks just like the residential site. All of the levels you see when school is in session drop, boom, back down as if school doesn't exist on that street at all. All right, so for those 2 data points, if you stopped everybody driving the kids to school and the buses, you drop back to normal levels. So school traffic is impacting this. And so what can we do? The things to come, and this is the reducing the idling of the buses, which Clean Air Carolina has worked a lot on. And then also it does become important, and Davidson has looked at this fairly well, in terms of route planning. So you've got charter schools, community schools, all these other things coming up, community centers, places that get lots and lots of traffic. You've got to take this stuff into account. You really just can't ignore it. So that's what came out of there. Finally, the people who pay for things, which is really important. So the Center for the Environment helped fund kind of all of the stuff we needed, including the miles on the cars, in order to do that. And then Merck, Davidson Research Initiative, the College Department of Chemistry, and the Stone Fund have helped fund all of these other studies up until now. And I want to thank you for your time and attention.